Hi everyone, this video is on exercise 9F, questions E and F. So this section of the differentiation chapter is all about differentiating, using different differentiation techniques, and specifically when you have trigonometric functions, because in this section we focus on how we can use our different techniques that we have learned in the previous sections in order to use them when we have uh, trigonometric functions as well as other functions. So in part E, the function is ln x over tan x, and we want to differentiate this. So f dash x is equal to, this is a quotient rule, we need to use the quotient rule. So we always square the denominator function as the first step in quotient rule, and then we write the denominator function times the derivative of the numerator function. So numerator is ln x, and the derivative of that is just 1 over x. So that's the first part, and minus, now we write down the numerator function this time times the derivative of the denominator function. So denominator function is tan x, its derivative is sec squared x. So it's one of those standard results that you can either memorize or just differentiate that directly. So in this case, yeah, so this is the derivative of f of x. Now let's do part F. So in part F, the function is e to the tan x over cos x. And this is an interesting one because we need to use several different techniques that we have learned in this chapter. So first of all, we have a fraction, so it's a quotient rule. We need to use the quotient. Also, if you look at the numerator function carefully, it's actually a chain rule because we have e to the tan x, which is basically we have two different functions. One function is e to the x, or just let's say e to the u for example, and u itself is a function, right? So u is tan x. So we have two functions. So yeah, we need to use the quotient rule, the chain rule, and of course we have trigonometric functions, so we need some standard results. Okay, so we start by squaring the denominator as usual because it's a quotient rule again, and then we write down the denominator function times the derivative of the numerator function. So this is the interesting derivative. So e to the tan x, it's an exponential function, so we always differentiate the exponent, and that becomes the coefficient of the exponential function. So e to the tan x is the exponent, and tan x, we know that it differentiates to sec squared x. So that becomes the coefficient times the function itself minus, on the other hand, it's the second half. So we write down the numerator function this time and the derivative of the denominator function. So denominator function is cos x, it differentiates to minus sine x. So minus sine x. And we can simplify this, but I think, yeah, that's not necessary in this case. We can just leave our answer in this form. So just to quickly recap, we start by having by using the quotient rule. So we square the denominator. Then we write down the denominator function first, which is cos x, times the derivative of the numerator function. So numerator is an exponential function, and we use that chain rule. So the derivative of tan x is sec squared x, so that becomes the coefficient of the function, which is e to the tan x. Then minus, this time we start by writing down the numerator function times the derivative of the denominator function. So denominator is cos x, so cos x differentiates to minus sine x. And this is the final answer. So of course you can go and simplify this, especially that we have some trigonometric functions. But again, if you are not asked to do so, then I would suggest that just move on. Okay, that's it for this video. Thank you for watching.